And there's a very specific behavior of y-intercepts that we need to keep in mind, which is that it's when x, or t, equals 0. Let me write that in a way that makes sense. It's when x equals 0, in other words, t equals 0. So we first want to find out what that intercept is, and then we need to interpret it in the context of the problem, which really just means, what does that number mean and why is it important? What does it tell us in regards to the story of this problem? You were trying to tell a story about when t equals 0, what does it tell us, right? So first we're going to go ahead and find uppercase T of 0. It's pretty quick and easy to solve for, so go ahead and do it on your own. Plugging in 0 for all of these parts of your equations, that guy goes away, and all you're left with is 38. So that's one part of your of this problem. Explaining what it means in the context of the problem. When t equals 0, that means at time equals 0. In this case, that means at 9 p.m. So at 9 p.m., Mr. Quelty's body temperature was 38 degrees Celsius. That's all you have to say, is you just have to, instead of giving me just numbers, you have to tell me what is the story of this answer. The story is at 9 p.m., the beginning of this process, Mr. Quelty's body temperature is 38 degrees Celsius, which is rather warm, but okay. All right, so that's our first foray into quadratic optimization. Let's talk about that for a second. Optimization, that's just because optimization, you're trying to find like the ultimate point, right? So optimization is like when you're either finding the minimum or the maximum. And so that's what this lesson is about, is how to take quadratics and find their maximums or their minimums and then interpret them in real world problems. All right, second problem. All of my whiteboard markers are drying out. This was an issue last year, not so much this year since we don't use the whiteboards. This means that it is time to throw them away, but I am too lazy to walk back to the classroom, so I decided to try out my mad basketball skills and throw the marker out. The marker's height in feet can be modeled by this equation, where x is the marker's horizontal distance from me. So let's mark that real quickly. X equals horizontal distance. H of x equals vertical distance. So what is the maximum height the marker achieves? Maximum height, we're talking about the vertex. But here, let's talk about it this way. Maximum is talking about the vertex, but height is talking not about the x value, it's talking about the y value or the h of x value, right? And so we don't want the x value of the vertex on this problem, we want the height. We want to know what is the maximum, not at what horizontal distance away from me is the maximum height of the marker. I'm saying just what is the maximum height of the marker. So we're looking for that y value. Now we only have a formula really to talk about the x value. So we're going to use that formula first, that negative b over 2a, to find out the x value, and then use that x value to find the y value. So we've just planned a strategy. We should write it down. It's a really important thing to be able to do, is to be able to write out your plan and write out your strategy. So we can say x equals negative b over 2a, y equals question mark. Right? That's a good hint of like, okay, I'm solving for y. Here's something that I can use to solve for y. You can even do like a little arrow. Okay, first this, then that. You've planned. Now, all these balls that you're juggling in the air in regards to this problem and your thought process, now some of it's written on paper and you don't have to worry about it anymore. Now you can just focus on the actual mathematics. Okay, so we have this formula. I want you to go ahead and solve for the x value of this vertex on your own. The x value of this vertex, negative b over 2a, is 4. So then plugging in 4 into your quadratic equation, I would like for you now to solve for the height of the maximum height that the marker achieves. Plugging 4 into this equation, we end up getting exactly 12. So the maximum height of the marker is 12, and it says right here in feet, so I can say 12 feet. That is quite the throw. Okay. If I miss the trash can, how far will the marker travel horizontally before it hits the ground? So if I've missed the trash can completely and I'm just hitting the ground somewhere, which is more than likely, we know that our parabola is going to look something, notice +4 here, which means that it was released at 4. So our parabola is going to look something like that. So this is 4 right here, our y-intercept, because if I plugged in zeros, those guys would go away, and so that would be the 4. We want to know what is this value right here, such that it'll hit the ground at that point. Because when it hits the ground is when your vertical height is 0. Your y, or in other words, h of x, equals 0. So again, part of the problem solving process. Oh, hits the ground, that's when I set this equation equal to 0. And, okay then, what is x? So I've planned it out, I've drawn pictures, I've labeled my variables, I've said what I'm solving for, a little piece of helpful hint. I've taken something from the verbiage of the problem and turned it into a mathematical way of representing it. Now I know what my plan is. I'm going to go ahead and solve for the problem. So I'm going to set my equation equal to 0. And solve for x. You have multiple ways to solve for x here. First of all, you could complete the square here if you like. It wouldn't be so terrible with that 1/2 being factored out. You could use your quadratic formula, or you could use your graph of your graphing calculator. Go ahead and solve. I'm going to go ahead and solve using I'm going to show you completing the square, because I bet you nobody did completing the square. Prove me wrong. Negative 1/2, I'm going to factor it out, minus 8x plus something, minus plus 4 minus, actually, so I added something, I'm going to be subtracting it away here, but the fact that it was being multiplied by a negative number means I'm actually subtracting it here, which means I'm going to add it here. 1/2 times that thing that I put in here. So in order to solve for this, I need to take half of this and then square it, which would make it 16. 16, negative 1/2 x minus 4 squared, plus 4 plus 8 would be plus 12. Solving for this being equal to 0 means I do negative 12 equals negative 1/2 times x minus 4 squared, divide by negative 1/2 is positive 24 equals x minus 4 squared. Square root plus or minus the square root of 24 equals x minus 4. Add 4 to both sides. 4 plus or minus the square root of 24 equals x.